Hello everyone, welcome back to my YouTube channel. Today we have a question here that reads, an Olympiad question that reads, find the sum of the first 5 terms of the series, 2 third, 4 ninth, and 8 27th, and so on and so forth. This is a series, and you're asked to find the sum of the first 5 terms. So when you see a series like this, it is left to you to detect, is it an arithmetic progression? Is it a geometric progression? So you have to detect that yourself. So we know that for it to be an arithmetic progression, it means that the second term minus the first term must be equal to the third term minus the second term. For it to be a geometric progression, it has to be the division of the second term by the first term should be equal to the division of the third term by the second term. Now, let's quickly dive right into what we have here now. You will see that from the series, we're given that from the series, we could say A1 is what? 2 over 3. A2 is what? 4 over 9. And A3 is what? 8 over 27. And remember I said for us to check if it's a common ratio, that is a geometric progression, common ratio, that is R, common ratio has to be what? A2 divided by A1 must be equal to what? A3 divided by A2. Now, let's quickly check that now. So if I do my 4 over 9 divided by 2 over 3, it is expected that it is equivalent to what? To 8 over 27 divided by what? 4 over 9. Now, let's quickly check if it's actually the same thing. So this becomes 4 over 9 times what? 3 over 2. Key flip change. So let's see, this is 2 here, 1, this is 2 here, 2, 3 here, 1, 3 here, 3. This is 2 third, right? This is 2 third. Let's see if we're going to get to 2 third when we do this. So we have 8 over 27 times 9 over 4. So if I do here, 4 here, 1, 4 here, 2, 9 here, 1, 9 here, 3. And this is a what? 2 third. So my common, it's the same thing. So it's what? A geometric progression. And the common ratio R is 2 over 3. Now the question says to find the sum of the first 5 terms. So what's the formula in finding the sum of the first 5 terms of a GP? That is a geometric progression. So sum of the 5 term rather is simply what? The A1 into bracket 1 minus R to the power of 5, that's the number of term, over 1 minus R. Remember, R is what? Common ratio. Now we have everything that we need here. Let's just slot in, substitute, and then we are good to go. Good to go, good to go. My A1 happens to be what? 2 third, right? 2 third. Then 1 minus my R also happens to be what? 2 third. 2 third to the power of what? 5. Now, all divided by 1 minus what? 2 third. Now, let's quickly dive into what we have here. This seems a little bit complex, but trust me, it isn't. So we have 2 third. Then we have 1 minus what? This is 2 to the power of 5 over 3 to the power of 5. Remember, all of this is being divided by 1 minus 2 third is 1 over 3. You can use your LCM calculators to do that. I don't think I want to do that for you. Yeah. That's in mind now. So we have that. What do we have next? So we have this becomes, so s of 5 becomes 2 third, yeah, over, I'll make this 1 over 1 minus, this is 2 to the power of 5 minus 3 to the power of 5, all divided by 1 over 3. So I use my LCM here. So this becomes 2 over 3, right? Which is equal to, the LCM here is just simply 3 over 3 to the power of 5, right? 3 to the power of 5. Then I have 3 to the power of 5. 1 and 3 to the power of 5 is 3 to the power of 5. Times 1, that's 3 to the power of 5. of 5 minus 3 to the power of 5 in 3 to the power of 5 is just 1 by 2 to the power of 5, that becomes 2 to the power of 5. And I close this. Remember, the whole of this is being divided by 1 over 3. Now, how do I make life easier for myself? I change this to multiplication, that is key flip change, and 3 comes up, 1 goes down. Then I can cancel out this 3 and this 3. So it becomes s to the power of 5 becomes 2 over 3 times 3 rather, times 3 over 1. Then remember, I have my 3 to the power of 5 minus 2 to the power of 5 over 3 to the power of 5. Then this becomes this. Then I have just 2 here now. So for me to simplify this, I'm going to teach you a simple trick from indices to do this. I don't need you to use your GCSE to this or your calculator to do this, just from indices. We're going to do that. We know already from indices that 3 to the power of 5 is the same thing as what? 3 to the power of 4 dot 3, right? Which is still the same thing as what? 3 to the power of 2, all bracket what? 2, right? 2 times 2 gives us 4 back from indices, dot my 3. So this is what? 3 to the power of 2 is simply what? 9, right? To the power of 2, dot 3 back. And this is simply what? 81, isn't it? So this is 81.3, which is what? Which is 243. Now you see, I didn't need my calculator to know that the 3 to the power of 5 is 243. Same thing is applicable to 2 to the power of 5. Let's do the same thing. So we have 2 to the power of 5 is simply what? 2 to the power of 4 dot what? 2. Then 2 to the power of 4, you really don't need to cram anything. Same thing as 2 to the power of 2, then all to the power of 2 dot 2. Now this is simply what? 4 to the power of 2 dot 2. 4 to the power of 2 is what? Is 16 to the power of 16 rather dot 2. And 16 dot 2 is simply what? 32. So what do I do now? Instead of writing 3 to the power of 5, I'll write 243. Instead of writing 2 to the power of 5, I'll write 32, and then I'm good. So S5, that's the sum of the first 5 terms, is equal to, remember I've simplified this here, so I'm left with just 2. Then this is 243 minus 32 over 243. And this is simply what? 2. Then this difference of this is 211 over what? 243. And my answer is just what? 422 over what? 243. And that's that about that. This is what you're expected to do. This is an Olympiad question. So like, comment, share, subscribe to my YouTube channel for more videos and more math tricks and tips. See you in my next video. I remain your global math teacher. Bye.